Welcome to a lesson on the payout annuity formula. In an annuity, you start with nothing, put money into an account on a regular basis, and end up with money in your account. We will now learn about a variation called a payout annuity. With a payout annuity, you start with the money in the account and pull money out of the account on a regular basis. Any remaining money in the account earns interest. After a fixed amount of time, the account will end up empty. Payout annuities are typically used for retirement. Perhaps you have saved $500,000 for retirement and want to take money out of the account each month to live on. You may want the money to last 20 years or more. This is a payout annuity. So here's the payout annuity formula, where P sub 0 is the balance in the account at the beginning, also called the starting amount or principal. D here is the regular withdrawal, or the amount you take out each time period. R is the annual interest rate expressed as a decimal, which is here and here. For example, 5% would be 0.05. K is the number of compounding periods in 1 year, which is here and here. And finally, N is the number of years withdrawals are made. N is here in the formula. Now, the compounding frequency is not always explicitly given, but is determined by how often you take the withdrawals. And this formula can also be used for loans, which we'll see in a future lesson. Before we take a look at some examples, let's talk about rounding. It is important to be very careful about rounding when performing calculations with exponents. In general, you want to keep as many decimals during the calculations as you can. Be sure to keep at least 3 significant digits, which means we include 3 numbers after any leading zeros. For example, if we were rounding 0.0001235, we would round to 0.000123. This number has 3 significant digits. And this will usually give a close enough answer, but keeping more digits is always better. Now let's take a look at 2 types of examples. After retiring, you want to be able to withdraw $1,800 every month for a total of 20 years. If your retirement account earns 3% interest, how much will you need in your account before you retire? Let's begin by identifying all the important information. Since you want to withdraw $1,800 every month, this tells us that D, the regular withdrawal amount, is $1,800, and because the withdrawals are monthly, K, the number of compounds per year, would be 12. You want to make withdrawals for a total of 20 years, so N is 20. And the account earns 3% interest, where R would be 3% as a decimal, and therefore R is equal to 0.03. And our goal here is to find P sub 0, the necessary balance in the account. So now we'll perform substitution into the formula and find P sub 0. So D is equal to 1,800. K is equal to 12, where K is here, here, and here. N is equal to 20. And R is equal to 0.03, where R is here and here. And now we need to evaluate this to find P sub 0. It's hard to evaluate this all at one time in the calculator, so we'll begin by evaluating this quantity here in the numerator, as well as this quantity here in the denominator. So evaluating this expression inside the parentheses in the numerator, we would have 1 minus the quantity 1 plus 0.03 divided by 12, close parenthesis. We're going to raise this to the power of negative 20 times 12. And notice how I included all 10 decimal places here in the second step. We could round to 3 significant digits, but again, the more decimal places we use, the more accurate our answer. And our denominator is going to be 0.03 divided by 12. which is 0.0025. So now we'll find the product of the numerator and then divide by the denominator. So in the numerator we have 1,800 times 0.450 777,286, and we're going to divide this by 0.0025, which will give us p sub 0. Running to the nearest cent, notice that p sub 0 is $324,559.65. So this is the starting amount or balance you would need in your account to begin with in order to withdraw $1,800 every month for 20 years if your account earns 3% interest. Now let's take a look at a second example. Here you already know you have $300,000 saved for retirement. Your account earns 4% interest. You want to know how much you'll be able to pull out each month if you want to be able to take withdrawals for 15 years. Let's begin by identifying the important information. So $300,000 is p sub 0, the starting amount or principal. The account earns 4% interest, and therefore R is equal to 0.04. 4% is a decimal. You want to withdraw every month, so K is going to be 12. And you want to make withdrawals for 15 years, so N is equal to 15. So for this problem, we want to find D, the withdrawal amount per month. So we'll substitute 300,000 for P sub 0, 0.04 for R, 12 for K, which is here, here, and here, and 15 for N. Notice here we're solving for D, so we'll first evaluate the parentheses in the numerator and denominator, and then solve for D. So starting with the numerator, we'd have 1 minus the quantity 1 plus 0.04 divided by 12, close parenthesis, raise the power of negative 15 times 12, which gives us this decimal here, and our denominator is going to be 0.04 divided by 12, which we see expressed as a decimal here. Now for the next step, we want to find the coefficient of D, so we'll find this quotient and then multiply by D. So 0.450, 640, 4955 divided by 0.00333333 gives us our coefficient here for D. So now we have the equation 300,000 equals 135.19215D. So to solve for D, we'll now divide both sides by the coefficient of D. So this simplifies to 1, so we have D on the right side, and this quotient will give us the value of D. So we have 300,000 divided by 135.19215. Running to the nearest cent, D is equal to $2,219.06, which means under these conditions, you'd be able to withdraw $2,219.06 every month for 15 years. I do want to go over one more example, but we'll take a look at that example in part 2. I hope you found this helpful.